My SS1 physics students, we are once more back for our lesson. Today we are going to handle a topic that says crystal structure of matter. This is a very interesting topic. If you want to major in physics in your second degree, you may talk about solid state physics. That's where I did my own second degree, and there you have to grow crystal. So crystal is a very interesting topic in physics. Solids are grouped into two, namely crystalline and the non-crystalline or amorphous. So if a solid is not a crystalline, it will be non-crystalline or amorphous. Let us define these two. Crystalline or crystal is a solid substance whose atoms or ions or molecules are arranged in orderly, regular, repeating pattern. Three things are there: be orderly, regular, and is being repeated. The atoms or ions or molecules are arranged in orderly, regular, and repeating pattern. Crystal. Then non-crystalline substance or amorphous substance is also a solid material whose atoms or ions or molecules are not arranged in orderly, regular, and repeating pattern. So this is the two solids. Then let us go more about crystal and non-crystalline substance. I will start with the crystal. In crystal, the force holding the molecules are very, very strong. Very strong. So it's called intermolecular forces, very strong. This makes the molecules not to be free to move. Just like a solid, the molecules of the solid are not free to move, they just vibrate in a mean position. But the molecules of liquid and gas are free to move. So the force holding the molecule are very strong. But in amorphous, the force is not very strong. Based on this, crystals have some properties which is very different from that of amorphous. So let us know the properties of crystal or crystalline substance. Number one, properties. Of Number one, they have high melting point. This is evidence that the molecules are very held with strong force. So before you melt it, it will take time. Try and move one hair from your body. You see how painful it is because the hair is being held with strong force by the rest of the body. So before you melt it, it will take time. Two, they are soluble in water. They are soluble in water. That's number two. And when you put it in water, they dissolve. Three, they have definite shape. They have definite shape. Sometimes you say you are figure 8. The shape is there. But if maybe you are so unfortunate to involve in maybe motor accident, you see the shape may not be there. People who may not know you may say, this man, look at how the head is. Not knowing that the head was very perfect before. So they have definite shape. Also another evidence that they have strong forces holding the molecule. They are either hydrated or hydrous, that's in chemistry. Is they hydrated, is there hydrous? They are not soft when heated. When you heat them, they stay strong, they are not soft. They have high refractive index and they have definite melting point. They have high melting point, they have a definite melting point. You know, there's nothing on earth that will not melt. It will melt when you have heated it to the required temperature. And that temperature for it to melt is called melting point. Even this rod or iron, if you take it inside a high furnace, they melt. Then let us go to properties of non-crystalline substance or amorphous substance, amorphous solid. Number one, they have no definite melting point. They have no definite melting point, so we will say they will get at a particular point. Number two, they have no definite shape. They have no definite shape. If you see that they are now opposite of crystalline substance. Number three, they soften gradually when heated. When you heat them, they soften gradually. They are usually insoluble in water. Not soluble in water. They are all anhydrous, are not hydrated. So these are the properties of the two, crystalline and amorphous substance. Do that. Now let us differentiate between the two. Let us differentiate between the two. Ask a question like this, differentiate between crystalline and non-crystalline substance. Crystalline and non-crystalline substance. You can use their property to differentiate them. You can use their property to differentiate them, or you can use even their definition to differentiate them. So, as I'm going to give you answers, I would like also for you to attempt to differentiate them in your own way. As you're talking, make sure you are doing your own. You attempt giving answers to them. Number one, I'll go with the definition. Crystalline substance are those substances whose atoms, ions, or molecules are arranged in a regular, orderly, and repeating pattern. Whereas amorphous, their molecules, ions, atoms are not arranged in a regular, ordinary and fitting pattern. Before I proceed, sometimes some of you will know the answer, but fail to put it in an acceptable language. When you have to differentiate, you must use whereas or why. Or to be on the safer side, you put it in a tabular form. Crystalline substance, amorphous substance. So it will be easier for you. The one you want, the left for you. Number 2, crystalline substances are soluble in water, while non-crystalline substances are insoluble in water. Crystalline substance has definite shape, while non-crystalline substance has no definite shape. If you look at it now, I'm just using their properties to differentiate. So I would like you to add others. I'm giving you the properties you can differentiate. Then the next is to explain terms used in crystal. Let us know the terms used in crystal. The first one is crystalline lattice or crystal lattice. Crystalline lattice or crystal lattice. I have to explain this. What is crystalline lattice or crystal lattice? This is the arrangement of molecules in ordinary regular repeating pattern in a crystal. The arrangement of molecules is called crystalline or crystal lattice. We have different types of lattice depending on its arrangement. We have cubic, have prismatic, and octahedral. There are 3 of them. Cubic in a cube form, prismatic in a prism form. Octahedral means 8 sides. Note that crystals of the same compound have different shapes. Crystals of the same compound will get different shape. Another term, isomorphous. Isomorphous. What is isomorphous? Isomorphous. Explain the term isomorphous. Isomorphous is a substance of the same crystalline shape. Substance of the same crystalline shape are said to be isomorphous. Substance of the same crystalline shape are said to be what? Isomorphous. The next is crystallography. Crystallography. What is crystallography? Crystallography. Crystallography. This is the study of crystal and crystal formation. When you want to do a crystal, want to study a crystal, what is called crystallography. That's study. Then the next one is crystallization. Or solidification. I call it crystallization or I call it solidification. What do I mean? This is the process of growing a crystal or forming a crystal of a substance, or the process of crystallizing a substance, or the process by which a substance become crystallized, or it is the process of crystal formation via mechanism of crystal growth. So, in other words, when you say crystal, we are talking about forming a crystal, growing a crystal. Crystal are not seen with naked eyes. You have to use powerful microscope. You grow it, you see it. I wish you take a course in physics and you enjoy the crystal structure. Then the next I will discuss is different types of crystal structure. Different types of crystal structure. Different types of crystal structure. We have simple lattice, have body centers, have face center. Before I draw that, let me quickly give you a simple crystal structure, a simple one. From there, I will draw the diagram from the tray. Some of you are good in drawing, some are not good. You have to learn how to draw a box. You have to learn how to draw a box. If this is a simple box, when I have, let me say, I'm talking about sodium chloride crystal. You have two atoms here, sodium and chlorine. If I use it to represent sodium, chlorine will be like this. If I use it to represent, if chlorine is here, the name should be sodium. What you get is what? Chlorine. Here should be sodium. Here should be chlorine. Here should be sodium. And here should be chlorine. So when you look at it, remember that this is an ion. When they join together, talk about the sodium chloride, and they have high melting point. The forces are very close, very strong. So you see this arrangement. When we are in primary school, sometimes normally they are allowed to sit like this, a boy and a girl, but not nowadays. So that is a simple arrangement. But if you are allowed to sit like this nowadays, I don't know what happened. You know better than myself. So to sit like this is attraction. I won't go into the bonding now. You know, have the covalent bonding, native bonding, all the rest. But this is electro. They transfer electrons. Electro. When we talk about this, we talk about marriage. In marriage, you don't nowadays you don't marry and then fire immediately because there's a bond holding it. You can go to court, and court may not grant that divorce. But when you talk about friendship, which is covalent, it can start in the morning, end in the evening. There's no bond holding it. So this is very strong. Because it is strong now, we talk about high melting point. So this is a crystal structure of sodium chloride. Then let me now, I say we have three types of structure. Have simple structure, have body center, and face center. Now, simple cubic lattice. One, simple cubic lattice. Remember, I've explained what they call a lattice. This is an example of it. This example, if I have to draw it, this is an example of it. The way I have to draw face center cubic lattice, FCC. This is SC. Number 2 is FCC. Face center cubic lattice. It's that structure. What you're going to do now, you know, when you get a carton of a packet of sugar, If you count, it has 6 faces. So what you mean that there is an atom at this face, atom at this face. No, this face is up and down. Atom at this face, atom at this face. So each face we get extra atom. They call face-centered cubic lattice. Before I proceed, examples of this. Examples of this. Because of sodium chloride, as I told you before. But for face-centered, we talk about number 1, zinc sulfide. Zinc sulfide. Zinc sulfide. Talk about copper. Silver, lead, aluminium. So these are the ones that have face center. That is extra atom at each face. Apart from 1, 2, 3, 4, 5, 6, 7, 8. Apart from 8 atoms, each face has extra atom. And they have how many faces? 6 faces. So extra 6 atoms. Then the next one is body-centered cubic lattice. Body-centered, BCC. Number 3. BCC. Body-centered cubic lattice. Then the building foundation. The foundation block is simple cubic lattice. From the others will now be incorporated. So body-centered means that in that packet of sugar, you see, when you take all the vertices to have one atom at the center, it's called body-centered cubic lattice. Example is chromium, iron, and platinum salts. So these are the 3 cubic lattices we have. Then I move on to uses of crystal. Crystal has many uses. When you see some clocks or watches, they will say quartz crystal. So in industry, you use crystal to manufacture our watches. Also, our wedding ring, our engagement ring, they are shining. So I made up of crystal. Our jewelry, normally women know what you put on your neck or your earring, all those things. They are made of crystal. Then in some restaurants or some homes are also decorated by crystal materials. If I wash where they are drilling water, there is a sharp object which they use to drill the land. The same way, when they are doing oil exploration, they are what they call drill bits. That's made up of crystals. So crystals are of many uses. Now let us round up by talking about types of crystals and the types of amorphous substance. Crystals have many types. Have diamond, have graphite, have, I give you an example, sodium chloride, copper, silver, and all the rest. Then under amorphous, you have charcoal, have powder, you have plastic, have glass. But there's a way you can distinguish easily between amorphous and the crystalline substance. You can rub your powder. I know that every morning women rub the powder. Very smooth. But if you are blind and you are given alternative, you are given salt to rub, by touching it, you say, no, this is not powder. You do see it, but by touching it. So, particles. The powder is smooth. If you put that salt in water, you see it will disappear. When you put powder in water or put charcoal in water, you see it will float. So this is a quick way of differentiating between crystalline and the amorphous substance. I'll round up the lesson by asking you some questions answer these questions at your convenient time. Number one is, and these questions that they are not very far away from what you see in WAEC. NEPU 2003, they were out to differentiate between crystalline and amorphous substance. NEPU. You should remember that what you will see in your WAEC, the foundation is laid at SS1 and SS2. So, kindly do this assignment. Distinguish between crystalline and amorphous substances. Give 2 examples of each. Name 3 characteristics of a crystalline and amorphous substances. Name 3 types of crystal structure and give an example of each. Explain the following terms: crystal, crystallization, and crystal lattice. So I have finished your week 3 topic. Next time I'll go to another topic. Thanks.